Alright, hi everybody. I'm going to do two relative motion examples. So this first example involves a person at the airport walking along one of those moving walkways. So how I've set this up is there are two frames of reference, or two places from which we could watch this person move. So this first frame of reference is called frame S. And the second frame of reference is called frame S prime. Frame S prime is sitting on the moving walkway, riding along with the person. So, one way that we could figure out the velocity of this object in frame S is by adding up two other velocities. So if you look down here, the velocity of the object in frame S, or according to someone who's standing over here, would be equal to the velocity of this frame with respect to frame S. So how fast is this moving away from this? We're going to call that Vs prime. So velocity of S prime relative to frame S, plus the velocity of the object according to S prime. So how far is this moving away from this every second? So let's put some numbers on here and just do a quick example. So let's say the person is racing to get to their flight, and they're moving at 3 meters per second relative to S prime. So they're moving away from this axis 3 meters every second. Let's also say that the walkway is moving at 1 meter per second relative to the ground out here. So that means S prime is moving away from S at 1 meter per second. So if we just use this little equation here, so the velocity of the object according to S then would be 1 meter per second plus 3 meters per second, or 4 meters per second. So if you're standing over here in frame S, you're going to see the person moving away from you 4 meters every second. Another way to picture this is to just add up these two vectors, 1 meter per second and 3 meters per second. We're going to give you a total velocity of 4 meters per second. If the person was running this way on the walkway, then you could do the same thing. You just use this little equation here. So the walkway would still have a velocity of 1 meter per second, but the person would now be moving backwards, so negative 3 meters per second, and you'd get negative 2 meters per second. So if you're standing here, you would observe the person walking 2 meters towards you every second. Now, my notation on the worksheet might have looked a little different, so just check this. It might look like this. So this might just be V, that might just be Vs prime, and that might just be V prime. But double check that for me. Alright, second example. This is a case of a boat in a river, so we're looking down at a river from the top. This is the top view. So if you're sitting in your boat and the river was cruising along, let's say at 3 meters per second for the current, then if you're just sitting in your boat and you need to draw a boat. So your boat would just move 3 meters every second to the right. If it wasn't turned on, there was no motor running or anything like that. You'd just be cruising along sideways with the river's current. So a typical physics question is, well, what happens if you are driving your boat in a certain direction? So let's say that you're going to start here at this edge and you're going to drive your boat that way. So what's going to happen here is not only are you going to move in this direction, but you're also going to drift sideways that way while you drive your boat. You're going to drift with the current. So let's say that you can drive your boat at let's say just 1 meter per second. So if you drive your boat at 1 meter per second, and that's 1 meter per second relative to this frame here, I guess we could call that one S prime. This will be S. Then, a common question is, well, how far downstream, call this delta X, how far downstream will you land on the other side? Well, we know that every second you're going to move 1 meter up. So we're going to move 1 meter up, and every second we're also going to move 3 meters over. So 1 meter up, 3 meters over, 1 meter up, 3 meters over, 1 meter up, 3 meters over. And you get this path. You're not actually going to land on these upper dots here. Your path is going to look something like that. So how do we figure this out? Well, we'd probably have to know the width of the river. Let's say it was, I don't know, 50 meters across. Well, I can do Vx and Vy graphs here. In the y direction, I'm moving 1 meter per second constantly. And I know I'm going to move 50 meters in the y direction, so that's going to take me 50 seconds. In the x direction, I'm moving 3 meters per second, and I know I'm going to be doing that for 50 seconds, so I can just figure out this area, and that's 150 meters, and I figured out how far downstream I'm going to land. Another common question is, well, what's your overall speed relative to S prime? So that's kind of like the last case where we can just look at adding the vectors. So if we look at this case, my velocity would be 1 meter per second plus 3 meters per second tip to tail. So my overall speed relative to S prime would be let's use Pythagorean theorem here. Okay, so c squared equals 10. So this would be the square root of 10 meters per second, and then you could even go on to figure out the angle at which you were traveling.